Hello everyone. In this session, let's talk about constant expression and what is the difference between const and constant expression. So, what is constant expression? Constant expression is basically a expression which is evaluated at the compile time. Okay, it can be used for variables or functions or user-defined types. With a lot of advantages using this constant expression. So, what are those advantages? So, since this is evaluated at compile time, there is a but chance that it will give a better performance, because if you want to evaluate a larger expression during the runtime, it will take a lot of time when actually you are executing the program. But if there is a possibility that that expression can be evaluated at the compile time, because it's always a constant thing, then you can save lot of runtime as your expression is compiled or evaluated during the compile time. So it will take some time during the compilation, but once after the compilation, it is evaluated to a fixed value, which is a constant value, which can be used during the runtime. Okay, so since it's a compile time constant, it can be constructed in the read-only memory, which is again an advantage. And since it's a compile time, by default it is a thread save. So let's see some examples. Okay, so when you want to declare a variable, example, uh, I equal to 10. So 10 is a constant value. Okay, so this constant value we are storing it in a integer variable called I. But since it's a constant value, it can be explicitly mentioned, okay, as a const exp. Okay, what does it mean? We are telling the compiler that this value of I will not be changed anytime during the lifetime of the program. So it is always I equals to 10. So if we want to modify I value to 20, is it possible? No, it shouldn't be possible. So it's a read-only variable. So what is the difference between this using const and this? Both will give the same result, right? Okay, so both will result into an error. So constant is not a const expression because it is not an expression. So let's say we have another variable called z equal to 30, and if you want to assign this z here, let's say this z is also constant, and you want to evaluate z into 40. Is this possible? Yes, it is possible. Because all are at the compile time. But where const expression differs, right? So it differs when you want to evaluate an expression during the compile time. Okay, let's say set into 40. So this I is a constant. Though I is a constant, this is the value of I is evaluated at runtime, not the compile time. let's put expr here. What will happen? It is throwing an error saying that z is not constant. So it is evaluating an expression, okay, and this expression has a value which is a variable, not a constant. It cannot be evaluated at the compile time. So by having constant, it works. Well, even though value of I is a constant, it is 30 into 40, but it is evaluated at the runtime. By telling compiler that this keyword const expr, we are forcing compiler to evaluate this expression during the compile time itself. There is no choice for the compiler now to do it at the runtime. Okay, so when compiler doesn't have a choice, it has to enforce certain restriction that whatever it is depending upon, it has to be again constant, or it can be another constant expression. So in this case, let's say if we make this as a constant, it will still work because it knows that this is a constant value. This again, it can be evaluated at the compile time. Now it can be another constant expression also. This is also possible. Okay, so I hope this is clear. So const expression is forcing the compiler to evaluate the expression at the compile time. But just by using the const keyword, it is not necessary that it is a compile time constant. The value of that constant can be evaluated during the runtime. Okay, this is the biggest advantage of const expression. So this is a part of the advanced C++. It started with the C++ 11. So const expression that in C++ 11. Okay. Now this is with respect to variable. Let's say you have a function fact int. This is a function that will calculate a factorial of a number. So what is the formula for calculating the factorial of a number? It is n into n minus 1 into n minus 2. Okay, so let's put it in a programmatic way. So if n greater than 0, then n into factorial of n minus 1. This is a recursive call. This fact of n minus 1, we'll call this factorial again. So let's say value of n is 5. So n greater than 0, yes. So 5 into factorial of 5 minus 1, 4. 4 will be called here. So again n greater than 0, yes. So it will be called with 4 into 3. So recursively it will call each of the values of, for each of the values of n. Okay. If n greater than 0, then it will call recursively factorial of n. When it reaches to 0, it will return just 1. Okay. So this is the formula. So let's say if you want to use this factorial function, okay, I want to evaluate a factorial of a number, okay, and example, let's say you want to factorial of a number 5, okay. So this is value is 120, okay, factorial of 5 is 120. But even though 5 is a constant, does this evaluate at the compile time? No, it will not evaluate at the compile time. It is evaluated at the runtime. Okay. So during the runtime, memory is being used. Since we know that this value, the number we want to calculate, is a constant value, can we do some optimization? Yes, we can do. What we can do? We can use constant expression. Okay. By doing this constant expression, we can tell compiler that we want to evaluate the factorial of 5 during the compile time itself. If we do this, this will also give the same result, but this is evaluated at the compile time itself. So this fact of 5 is replaced with the 120 during the compile time itself. Let's say if you want to pass a value 5 to this factorial, okay, does this work? No, it will not work because I is a variable. Okay, it is not a compile time constant. So const expression, you are telling the compiler with the keyword const expression that this has to be compiled, this has to be evaluated at the compile time. But since we are passing the variable which is not a constant, so it cannot be evaluated at the compile time. So that's why compiler is throwing an error. If you don't use const xpr here, will it work? Yes. Again, this is as good as okay. That's a previous situation of so as good as evaluating at the runtime. So this is very important. So this is a small number. So I is a 5 is a small number. What if the value of I is big number of 100 or 1000? Let's take example of 10 itself. So when the value of this is 10, since it's a const exp, we have to make it as a const of const exp. So this is a very big number. To evaluate it, it will take many CPU cycles because it will calculate 10 into 9 into 8 into 7 into 6 into so on up to 1. So this will save a lot of space, a lot of time, a lot of CPU cycle during the runtime because it is evaluated during the compile time itself. So this is the biggest advantage of const expa. So just a recap, const expa will tell the compiler that it has to be evaluated at the compile time. There is no other option for the compiler. It has to be evaluated at the compile time. In order for it to evaluate at the compile time, it has certain rules. What are those rules? The const xpr should depend on the values, which is again can be evaluated at the compile time. In this case, const I, either it can be a constant or it can be another constant expression. Okay, 10 into 20, whatever it is. Okay, like this. So this is a advantage of constant expression. So one more thing, in C++11 of advanced C++, this const expf is introduced, and this const expf function has to return a value. There has to be a return statement. So without this, it will not work. So that's it about constant expression. We'll see you in the next lesson. Thank you.